Technologies webcast on application delivery. My name is Becky Bailey, and I'm the Business Communications Manager at A&I Solutions. For those of you who may not know, A&I Solutions is a services provider and software reseller that was founded almost 15 years ago in 1999. Primarily, we focus on solutions by CA Technologies. Since 2004, A&I Solutions has been a strategic North American services partner of CA Technologies. Backed by the support of our partnership and experienced services team, we've become a leading provider in enterprise solutions dedicated to delivering dependable products through excellent people at a fair value. And at this time, I would like to introduce today's guest speaker, Burt Klein, Senior Customer Advisor at CA Technologies.
Thank you. Can everyone hear me okay first? Moderator, am I coming through clearly?
Yes, you are.
Thank you.
Yes, we can.
Well, thank you. Just want to confirm, and the screen hopefully everyone's able to share and see clearly. As stated, my name is Burt Klein. I am a customer advisor within the application delivery space. Today, we're going to take a short walkthrough of what application delivery is from CA Technologies and how it can help your organization, your business move forward, and hopefully solve some of the same problems we're seeing across the globe with other clients will resonate within yourself. Currently, there's three major problems we're seeing within technology, specifically from the application delivery perspective. We're all being asked to deliver faster to market in order to beat our competition, drive revenue, or solve problems which currently exist, bugs as we know them. At the same time, we're being asked to improve our quality, or at least maintain the quality we have, while improving our overall customer experience. All of this is being asked to happen while we're making more and more complex applications that are constantly being upgraded for new releases and interfacing with different IT partners. You factor in these three simple things of faster, higher quality, complexity, and then also add on top of that the fact that we're being asked to drive down our overall cost of ownership and our cost to develop and do all four things concurrently. And it's easy to see why people are having difficult times doing so. Generally speaking, to deliver something faster means more bodies. To improve your quality means more people or more time spent doing dev and test. Both of those drive up cost. Today, we're going to talk about some new capabilities that have come to market that will help you increase your speed to market, improve your quality, control or decrease your cost, and do all three concurrently. In today's business environment, we're taking in technology something that's been around for 30 years in manufacturing. We're starting to look at using our software development under the lean methodology. As you notice from this graph, pretty much outlining what most folks do for software development, the areas in green are actually denoting value add time or touch time. When someone's actually doing value add work against the product they're building, against testing of that product or deploying of that product being a software package, an integration of packages, or new components going into production. The gray time is denoting idle time or non-value add time. When we're sitting waiting for someone else, waiting for something that we need in order to move forward, or just being held up because we're not ready for the next phase of our testing and development cycle. These challenges hit most every organization, and what we're looking to do at CA Technologies is help you reduce the size of the gray areas while increasing the size of the green areas, which ultimately drives your speed to market as well as your quality up. The more time you can spend with your hands actually on the products you're developing or integrating, the less time waiting for constraints, you will see improvement in quality as well as quicker time to market. This is all done through a collection of tools, suites, and processes that will hopefully make you much more productive while controlling your cost. There's primarily 4 C's as we see them at CA Technology for the whole development operation cycle, or DevOps as the new term has been coined. Those 4 C's are pretty straightforward, but at the same time, they're not very easy to deliver. How do we sit and allow our developers and testers constraint-free development and testing? Meaning that a developer has everything at their fingertips, on their laptop, on their desktop, where they can write their code, integrate their products, do all of their testing while not being held up waiting for someone else. At the same time, having testers where their data is available when they need it, the ability to interface with systems downstream that are service providers to them while not being held up or waiting just because somebody else is not available. The next big thing is how do we move out of constraint-free development and actually continuously application delivery? How do I take what I've built and move it to the next environment, whether it be an integrated test environment, a system test, a UAT, or a performance? As most of you probably realize, moving your artifacts, whether it be a package code or homegrown, is a major event. And I'm not just talking the one application, I'm talking the whole release. How do I take my new software upgrades for my app server, along with the code that goes along with it, with all the property files, everything that integrates to upstream and downstream, and move it as one cohesive package from one environment to the next. Most organizations I talk to and that we hear from are telling us this takes anywhere from days to weeks. To pick up their application and move it from one environment to the next is something that is very time-consuming, very manual, and very error-prone. We at CA Technologies are going to talk through in a minute here how we have capabilities to help take those weeks down to hours and minutes. Once you get that application to the next environment, and that next environment ultimately being production, the most important thing for production is how do I get those production artifacts out of production and back into my pre-production environments, so when I do my development and I do my testing, I'm doing it at the production-like level. And what I mean by that is response times for my applications, the same as production. Data packets, the same as production. Same mix, same size, same quality, but sanitized. Not using real production data, but real production-like data so I can properly test the artifacts in test, as well as recreate issues should I have one. Taking all that information out of production, feeding it back into my pre-production environments, which ultimately will help you improve the quality of your product that is going to go to market. Let's talk about how we do these one by one, but the ultimate goal is how do we close this loop? Constraint-free development, continuous application delivery, into a complete monitoring environment, and solution in your production, feeding it back into the pre-prod to improve the quality for the next release. First and foremost is constraint-free development. The time we spend in development is non-value add to the business. We're not earning revenue, we're not decreasing cost, we're not offering new features. At some point we will be, but the longer we spend in prod, the less value it brings to production and to our customers. The product CA LISA, acquired about 18 months ago from a small startup firm, has been hitting the market by storm. It is probably the most prevalent application or software technology tool that has been out there in the last 5 years. What it allows you to do is pretty simple. The top line designates how most people do development today. Multiple development teams doing a little bit of development and then waiting for somebody else. They go down a traditional waterfall. They hit their system testing, their integration testing, their performance testing, and UAT. What LISA allows you to do is intelligently simulate a business application. And what I mean by intelligent simulation, I'm not talking just mocks and stubs. We've done that technology now for 30+ years. I'm talking the intelligence that says, on an online banking application, for example, maintaining from sign-on to account overview, to account detail, pay bills, move money, buy stock, go back to your account overview and see all of the transactions that you just committed reflected in your new balances. And do it against simulated applications. You're not hitting real backends, you're not hitting real databases, you're hitting an intelligent business simulated application. By doing that, what it allows people to do is actually give our development team a full view of the ecosystem that they're writing code against. So think about what it does for your developers. If you had every interface you needed to call set up, the appropriate amount of data to do all of your testing and all of your conditions that you could develop without any constraints, what we're finding with numerous success stories in the order of magnitude of multiple hundred large Fortune 500 clients are coming back and showing that they are seeing the development going quicker. Your development teams can run independently, and when they finally do integrate the system integration and testing, they realized higher quality because the developers had the ability to properly write their code in an environment that looks like production, something we don't have today. So ultimately what this has done is created a new shift-left terminology. And this actually came from a CA customer. What they're saying is they're seeing their Gantt charts and their project plans shifting left dramatically in the sense of delivering products to market faster. And more importantly, they saw their quality going up at the same time. Because now the developers and the testers had the ability to put in not only positive test conditions for data, but negative test conditions, and reset those conditions almost instantaneously. And ultimately what they received, faster to market, higher quality, reduced cost, all done concurrently. At the end, we're actually going to have a demo of this because most people at this point stop me and say, okay, where's the magic pixie dust? So we actually have John on the phone that's going to run you through a demo here at the end. And I think, are there any questions at this point?
Actually, yes, Burt. This is Stacy with A&I Solutions. We had a question come in. The question is, what other common use cases does service virtualization address?
Great question. The most common is shift left. There's 5 big common use cases. Shift left is most common. Second one is removing hardware infrastructure. Think about it. When you're writing business applications and you're doing a new application development within your release, you're not changing every application. So why am I standing up hardware for every one of them? Generally speaking, what we're seeing from market research is anywhere from 15 to 25% of your applications change in a given release. That implies that 75% or greater do not change, which means you're setting up environments which aren't necessary. If we could run them virtually, they run an x86 blade, a lot of money can be saved on hardware. Third big use case, performance. I have yet to meet an organization that is able to do performance testing in an end-to-end environment and tell me that they're comfortable with the results. Majority of them want to do it by component by component. Same way we do the space shuttle, same way we do an airplane, same way we do a car, so they know the breakpoints of each component. It's very difficult to slow down a large mainframe, but with service virtualization, we simulate the mainframe, I can slow it down in a matter of seconds. Fourth big use case is data. Anybody that works in a testing realm or development realm understands how important data is and how difficult it is to condition. You go out there, you get your data conditioned, you're ready to run your test, and oops, somebody went out and modified one of your record, so your automation or even your manual testing no longer gives you the results you expect. And then the last big use case, the top 5, is actually virtualization of your network. I can simulate with these capabilities a mobile phone driving from DC to New York City and what they're doing across the online application you have. Going from 3G to 4G, back to 3G to a place where they have next to no connectivity, and truly simulate that application across the network and what it does to your back-end systems as well as the user experience. The reason all 5 of those use cases are so important, we as application delivery need to understand how our application is going to behave as well as the user experience before it goes to production. I can give you countless cases where people wait and put it in production and say, we'll figure it out in production. They have a failure, and folks, let's be honest. If you have a failure in production, it goes against your brand and reputation. It's no longer the day where if someone has a failure in production, they tell 1 or 2 friends. They go out to Twitter and Facebook and post, and next thing you know, they've told thousands of people in a matter of seconds. So having your brand supported by higher quality, getting your products to market faster, not missing deadlines, not sliding dates when you've already made commitments to the market, as well as making sure it's going to perform properly, both from the end user component as well as your internal components behind your firewalls, are what's key. LISA addresses all of these, plus more. Stacy, any other questions out there?
Yes, I actually had another question come through. If you could help us understand how this compares and contrasts to the known open source equivalents.
I'd love to, but I don't know of any open source equivalent other than tools that do mocks and stubs. I know of 2 that do mocks and stubs, and what a mock and stub is, you go in manually, you code up, if I pass in Burt, I get back Klein, it's done. There is no mock and stub that will keep track of information that I'm aware of this is, back and forth from sign-on overview count detail, pay bills, move money, that whole transaction, and show you the results coming back as a business transaction, what the consumer sees, not a technical transaction. To be honest with you, there is only one other product in the market that is even going after this space, and they're 5 years behind. So if a person wants to email me about what they're seeing out there, I'd love to hear about it if there's something new I haven't seen. But to date, I have yet to find one that even comes close to offering this capability. Reason being, the folks at the CA bought a couple years ago, they developed it, they patented it, they've got a pretty good lock on it for the time being. Other questions?
Nope, that's it for right now if you want to continue.
Okay, thank you. So next thing out of constraint-free development, giving our developers and our testers the ability to do their job when they need to, how they need to. Hello, computer. There we go. What we're actually seeing, and this is a large U.S. telco, this is just a sample of what they saw on their first project, first time using CA LISA. Reduced the cycle time by 1/3, caught 400% more of the defects earlier in the life cycle, and they received a 100% return on their investment in 4 weeks after using this tool. What you notice though from the top is they actually had where the dotted lines are showing what they had planned for their testing timelines, and what really happened, everything started shifting left. They condensed the timelines because they're able to do it the whole day, whenever they wanted. They weren't waiting. Basically, they took and used the full 24-hour clock where appropriate. Other times when they were only working a single shift, they were truly working the full shift instead of waiting. One of the biggest things out there is how do I get my artifacts and my product from one environment to the other, from dev to unit to integration, etc. Again, this is talking waterfall. These capabilities work just as well when you're talking agile, but most large organizations today are just starting to dabble in agile. Most of them actually do something called agifall, a bunch of sprints to write the code, then they throw into a waterfall from testing on through production implementation. But the new continuous application delivery within this space, the release automation, this is not a replacement for your scripting tools if you have them like Jenkins and others. This is an umbrella that will make Jenkins even more powerful. What happens is you sit there and pick up your artifacts from many different components. Web servers, app servers, hardware, network components, database, Unix databases, and you have to move it from one environment to the next. I need to make sure I'm taking the appropriate artifacts that go together as part of this package, pick them all up, move them over, drop them down, have the property files changed accordingly to point to the different hardware or different MQQs or different backends that represent the integrated environment or the performance environment. That's a very time-consuming task. Even if you write manual scripts, it's a time-consuming task to maintain those manual scripts. What release automation does for you, it takes at a higher level and takes whatever you might have today, if you have anything. If not, it helps you automate the scripting to say, here are the artifacts. They get picked up, they get moved over, they get dropped down into the next environment. Here are the key fields that need to be changed from dev over to integrating testing, and changes them for you. And the whole time it does it in an automated fashion where it stops the environment, moves the artifacts. Well, first it checks for space, move the artifacts, bring it back up, and run a smoke test. It goes as far as to say, if you tell it I'm adding 2 new web servers to my production environment, it knows when it's getting ready to do the deployment that it first must build those web servers up to the base level of what production is today before migrating the new code. So think of all the manual steps and manual efforts you're going to take out of what you do today. What most people do today, and I lived it for many years, is you get 20 to 30 people on a call. You have someone being the conductor of the orchestra saying, okay, back-end guys, quiet your database. As soon as they're done, they start moving their back-end code. Then they go to the mid-tier, then they go to the front end. And they basically have a traffic cop or an orchestrator at the front, a conductor, telling people one by one when to do their components. And remember, if you have 20 web servers, you have 1 or 2 people doing it manually, it's difficult to do all 20 at once. With this capability, it does it for you all 20 at once. It doesn't sit there and have to have one person typing on a keyboard. Through the automation, it knows what can run concurrently, and it moves it much faster with a higher degree of confidence that what's going to be moved is going to be accurate, and then restarts it all for you. Think of what that would do to your release weekends when you sit there and have people moving bits and pieces at a time making sure that you have enough space and doing it all manually. People need breaks. With a computer doing it through automation, takes it to that next level. Questions on release automation at a high level? Because we're going to go into a little more detail. Next big one we're going to come to is the whole data mining and complete operations. What happens today is most test environments have no reflection on what production looks like. Your dev and test, you might have boxes, you might have applications, but they really don't reflect your concurrency in production, how many databases you're running, whether it be 1 or 5 at the same tier. It has no reflection on the size and the scale. The different components are at different levels, and the data is nowhere near what you have in production. Not only from the volume, which is not as most important, but from the data mixed. What we have now is the capability out there within CA Technologies to actually allow you to harvest the production-like data, as well as the performance characteristics, and feed them back into your pre-prod environments. Think about it for a minute. If you could actually simulate your production response times in pre-prod, so when you're running your application, you say, okay, my back-end systems can respond between 0.2 and 0.4 seconds. You can see what happens to your application tier layer, how much memory is held onto, what are the response times, how things are behaving. Think of the value that adds. You'll find out in pre-prod if you're going to have a problem at 100% capacity, or do you see a problem at 50% capacity where it's not meeting your SLAs. You want to simulate a mainframe slowdown or a back-end slowdown. That's next to impossible to do, but if I could do that with LISA, which is very simple in test, we now know how to tell our production teams when you're seeing certain artifacts happen in production, take a look. You might have a slowdown of an external interface. Maybe somebody kicked off a batch job during the middle of the day that shouldn't be running. But by doing this, we have the capability to pull information out of Wiley, as well as other artifacts, feed it back into CA Pathfinder, as well as CA LISA, all the way back into dev and test. So all your production characteristics, all your transaction mixes, as well as pull your data, subset it, sanitize it, and build it into those virtual services. Don't have to populate it to real databases and test. We don't need them majority of the time. Put them into a virtual service where you don't realize that you're hitting a simulation versus a real. We have those capabilities, and we're seeing great returns, or our customers are seeing great returns on their time, their expense, and their quality going up dramatically, because now not only do they test the positive conditions, the normal sunny day data conditions, they can go in and tweak it and put in negative conditions. What happens when I get something that we're normally not supposed to see? A customer with 4,000 accounts, a customer that has bad data. We can actually simulate that. What this does is help your quality go up. And being able to do a data refresh in instant or minutes versus what it normally takes today, weeks and months, a new fresh pull of data from production and sanitize it. If you could do that in minutes, think what that does to your time, as well as the number of people you have sitting doing your data conditioning. Why are we doing it manually when there's tools now available that will do it for you? So here's the outcomes. Here's what people are seeing, and these numbers are not CAs. These numbers actually come from a multitude of organizations, including Voc, which is a market research firm, Forrester, and there's a third, I have to go pull the name, but what they've done is some market research, specifically around service virtualization. We're seeing a reduction in the software development lifecycle time by 25 to 50%. And remember, LISA does not help you in the architecture or the design phase, but you're still seeing a 25 to 50% time savings across the whole end-to-end. They're finding defects. 60 to 90% of the time, the defects are found in 1 or 2 phases earlier than they are today. People are finding the defects in dev in the first integration point because they now can run automation and run their testing against simulated applications and truly test their component. Just think about the value of finding your defect in dev or in integration testing rather than UAT or performance. We all know how much it costs to fix a defect when it gets to UAT or to performance testing, the time, the delay in the project, the number of people involved, where if I can catch it at dev time or the very first integration point, it's much cheaper to fix. Infrastructure costs are going down substantially. You're not buying a lot of big hardware. There are multiple organizations that are saving tens of millions of dollars on dev test environments, including performance environments. There's one organization that we know of that saved over 60 million hard dollars over 5 years on infrastructure alone for pre-prod, one of our clients. From release automation, people are taking it from weeks down to minutes. Multiple use cases, multiple clients willing to talk to you on the record about what it's done for their organizations. Automation errors or outages are almost eliminated. Once it's set up and goes from dev to test, going from test to integration, integration to performance, then to UAT, it's all automated. Your chance of having errors getting into production are so minute, it's almost nil. The ability to scale much faster. Adding 3 or 4 new app servers or web servers, system knows automatically how to bring it up to the production base level and does so without having human intervention. And then last but not least is the data mining, the ability to shift defects to the left through the automated coverage, as well as reducing time and effort to create production or live-like scenarios. These are the responses we're hearing from customers using these capabilities and what it's done for their organizations. So to kind of wrap it up, most important things that you need to understand coming out of what application delivery and some of the new capabilities in the past, some of these were just announced in April, but the past several months to the past 2 years, the ability to continuously deliver without constraints that doesn't cause any idle time. How much more time am I spending touching my product? The ability to shift left. Quality does not, you do not test in quality. Quality is designed in and built in. Being able to find any quality issues 2 phases early in the software development lifecycle to make sure the deployment happens in minutes versus hours, days, and weeks. And last but not least, 10+ million per large environment. If you're able to reduce that and not build out that new large infrastructure, think what that does to your organization's bottom line. Many, many clients, many, many use cases, many, many success stories of people doing this just in the last 2 to 3 years. With that said, now we're going to go through, since I'm going to take questions here in a sec, but yes, go ahead. Let's take questions before I go to John.
Sorry about that, Burt. This is Stacy with A&I again. I actually had another question come through. The question is, where do these metrics come from? Are they CA internal, or are they from other industry sources?
These are not CA metrics. CA reuses them, but they're coming from the industry, Forrester and Voc. All the data on service virtualization comes from a company called, well, Voc or Forrester. I do have supporting documentation. If someone wants to drop me an email, I can point them to the website. Voc went out and did a massive research around service virtualization back at the end of 2012. Talked to over 200 clients using it, up and down the executive, down to the practitioner level, all disciplines, global. They came out, these numbers are what's going on around the globe using this capability. But please note, over 50% of the respondents said they've only been using service virtualization for 2 years or less. And the reason for that, it's only been out since 2007. So it's a relatively new technology and capability, and most people are just starting to get involved in it in the last 2 to 3 years. But I have all the information. Actually, I can point you to their website where their information is housed, or on servicevirtualization.com, there's a link to it. You can pull it up and it will walk through all the metrics, how they got there, the demographics, who they spoke to, within which disciplines, which verticals, and gives you all that background. From the perspective of moving the code through, that was through Forrester and some research they have done. But no, these are not CA metrics. If we told you our metrics, they mean very little. You want to hear what's coming out from the market, so that's what we want to share. Other questions, Stacy?
No, that's all I had for right now.
Okay, since now most of you are thinking this is magic and pixie dust and doesn't really work, luckily we have one of our senior consultants on the phone. John has been with CA Technologies for over 15 years and working in many different disciplines. And he's actually going to walk through a demonstration for you of how the capabilities work so you can get an idea about it. Because believe it or not, the first time I saw this, I was a customer. I didn't believe it either. I wanted to see it not only run on a demo, but I made him come in and run it in my shop. So that's kind of what John does for us. And John, I'm going to hand the phone over to you and let you run with it.
Very good. I am John Bobinger, a senior principal here at CA Technologies. And what I want to do is I want to start by showing you a demonstration of an environment that we call Lisa Mank. And basically what we have is a kiosk emulator, which will then be speaking to our web app over port 8080. It has a number of backends. When we do more detailed demonstrations, we actually take apart the backend so you can see what happens when we emulate just a database or we emulate just the enterprise Java bean section. But what we're going to do today is we're going to emulate this entire backend. We're going to start by showing you what happens before we invoke Lisa, where we have a kiosk talking to this web application and doing its backend. So the Lisa kiosk application looks like this. I select my name and I log in. So this is talking to the real backend at the moment. And I can go to my checking account and look at my statement. I can go to my savings account and look at my statement. Go back, check my balance, and so on. So what we have here is basically this back end that does what you would expect sort of a banking application to do. So the way we work with Lisa is, what if what I want to do is to emulate this entire back end? What we're going to start off by doing is by doing a recording. So what that means is we're going to insert Lisa in the middle, in between the kiosk and the back-end application. So what we're going to do, we're going to tell the kiosk, instead of going to port 8080, which is where the back-end application lives, we're going to have a Lisa recording session going on port 8001. So what you're going to see is we're going to do a transaction similar to what you just saw, except that we're going to record each of the transactions that take place so that Lisa will be able to emulate those transactions in the future. So to do that, this is what the Lisa user interface looks like. And what I'm going to tell it is I want to start by creating a new virtual service image by recording. And we'll give it a name, record2. We will tell it that we're going to be using HTTP, treat transactions as stateless. We're going to build a model file, which we will also call Lisa record2. And as you can see, we're going to be listening on port 8001. We're going to act as a gateway here on our local machine so that it will be listening on port 8001, but then passing all the transactions to our real backend at 8080. So we will then say, and so now it's acting as a recorder. I go back to my kiosk and I tell it I want it now to communicate to the backend on 8001. I make sure that it's communicating, and it is. So once more, I select my name, I log in, give it my PIN, and I can go to my checking account, view my statement, go back, look at my balance, go back, and in fact I can transfer $100 to my savings account. And then let's go take a look at my savings account. There's my statement, including the transfer I just made. Take a look at my balance. And with that, I'm now done. So we cancel to log out, and now we're done with the kiosk. If we go back to Lisa Recorder, you'll see that it has been recording the transactions that we just made. So I'll tell it now, let's go ahead and turn those transactions into a Lisa virtualized service. Let's take a look at the service image and the model. So you can see that it says I'm going to be listening on port 8001. With each transaction that comes through, it will then route it to the appropriate response and send the appropriate response back to the original requester. The transactions that it saw included, I'm logging in, various transactions, transfer money, get the account, and so on. So now what I'm going to do is I'm going to take record 2, the one we just made, and I'm going to deploy it. So at this point, I now have record 2 listening on 8001, and it's running and ready to handle transactions. So now, when I log into my kiosk, these transactions aren't being handled by the actual Lisa Bank backend, but instead it's being handled by the Lisa Service Virtualization. So at this point, I'm not touching the backend. Everything that I'm doing is coming from the virtualized environment, including such things as I want to transfer $100 into my savings environment. On another transaction, let's go back, let's take a look at savings. So it's acting exactly as if I were talking to the real back end, but everything now is being emulated. In fact, now I complete that operation. If I come back to my service console, I can see that indeed I have had communications and I've done 5 transactions using that emulated backend. Now this is very useful if you already have a backend to emulate. What if you're in a development environment and all of the components are being done individually? What if all I have at this stage are just specifications? So for example, let's suppose that I am building something and all I have to communicate, or all I have as a specification for the backend is a WSDL. Well, then what we're going to do, we're going to create a new virtual service image from a WSDL. We'll call this one WSDL 2. We'll load the WSDL, which, by the way, as you can see, could be on the network, but in this case, I happen to have it stored as a file. I can say whether or not I want all or none of the specific operations that are inside that WSDL to be part of my virtual service image. Again, you'll see I'm going to be listening to it on port, let's make this one 8002. And of course, it's a SOAP transaction. And so with that, it has taken the WSDL and created a virtual service image of it. So I can see the transactions add an address, add a user object, delete address, delete a user. So all of the individual transactions are now set in here. Now, more than that, we know what each of these, of the content of these requests is going to be. So, for example, we know that a name is going to be an alphabetic. We know that an account is going to be numeric. We know that an address is going to be an alphanumeric because it's going to contain both letters and numbers. So one of the things that this enables us to do is it allows us to say, oh, I know what this is supposed to look like. So I will accept the format that that comes in. And if I see that it is not a matching format, if I have, for example, alphabetics in a social security number, I know that that's a bad thing and that I should signal an error and going back. So I can create a virtual service image based on WSDLs. What if all I have are request-response pairs? Well, I can do the same thing here, where I can create a virtual service image based on request-response pairs. So we'll call this one request-response 2. We'll give these as stateless transactions. So again, if all I've done is find a way to put all I've done is been able to find a way to get request response pairs, then I'm going to be all set. We'll say this one we will list on 8003. Again, gateway, local host. If we do want to pass to the back end, we can do that on 8080. And once more, I now have created, based on the request response pairs, which just happen to have basically just get user in there. It's also possible to create virtual service images from scratch. If all I have is just an idea of what this backend is going to be, I could go in and manually create them. I could take the transactions that I have here and I can edit them. There's a number of things that I could do to create them. But as you can see, it's not a difficult operation. It's not a lot of magic in order to create a virtual service. Any questions? This is a very brief demo. Are there any questions on what you've seen here in the demonstration?
Hey, John, there is actually a question that came through.
Yes.
Can you hear me?
Yes.
Okay, just wanted to make sure. If an organization has a number of OSS tools in production on the release of this tool set, will this integrate?
Yes, it can. It depends on what those tools are. Specifically, what kind of tools was he talking about?
You know, it doesn't list that, so maybe we can just wait till the end and allow. Well, oh, I'm sorry, they just sent it through. Puppet, Chef, Jenkins.
Yeah.
Anything like? Okay.
Yes, they can. There are actually a couple of phases to what we're talking about in sort of the overall LISA environment. So, for example, in the service virtualization space, the demonstration you've seen right here, this is all about emulating what goes on in the back end. The LISA release automation is all about taking those existing tools, such as Jenkins and so on, and using those to rapidly deploy an application into the environment. What we mean by that is, if you sort of take a step back at the entire release environment, where you have your source code library, where you have your build tools, where you have deployment tools, where you have your testing tools, and so on, what we can do through the LISA release automation environment is to call those tools, those existing tools, in order to create the continuous delivery environment. Now, as an example of that, one of the things that you could have is, so you have the release automation calling your build tools, then it can call the deployment tools to put them in operation, and then call LISA Service Virtualization, and either your own front-end test, or LISA also comes with its own front-end testing, in order to do the sort of the first level of validation tests against the code that we have just deployed. And then we can present the results of those tests in some sort of for example, a service test ticket, and then say, are you ready to go ahead and put this into deployment? So what we do is we put a wrapper around your existing build environment so that we can automate the build, deploy, and test so that you can get a much faster result in terms of, I have this change that I want to make. Tell me whether it's going to break something. Well, we can rapidly deploy it to the test environment using LISA Service Virtualization as the back end. And then once that change has been blessed, we can rapidly deploy it again into the production environment. We've seen reductions in the time it takes to put an application into deployment for some customers, where it used to take them 12 days, and now it takes them literally 10 minutes. Are there other questions?
We just had another question come through. How difficult is virtualizing the calls to a database?
Calls to a database. One of the things that we provide is JDBC emulation. So, for example, if I were to go back to my picture here, if one of the things that I want to do is to emulate a database, then we have a JDBC emulation, which we can do, and that allows you to do JDBC calls to SQL Server or Oracle or anything else that accepts JDBC. That, by the way, is one of our major use cases, where an organization is attempting to test an application and they're basically told, that's nice, but you can't touch my data. So rather than try to build a test database or something along those lines, what we do instead is we can have a JDBC drive, a JDBC emulator, so that you can emulate that part of it. And by the way, it's also possible to have multiple LISA components emulating multiple things. I might have one LISA emulator doing the JDBC. I might have a different one doing SOAP emulation of another component. I might have a different one emulating calls to a third party for doing things such as credit checks or credit card validation. So I can have multiple components in the back end. But yes, emulating database calls with JDBC is one of them. Do we have any other questions?
At this time, I don't see any other questions coming through, so if you want to proceed, you can go ahead.
Well, very good. That completes the demonstration portion, and so I can return to you.
Stacy or Rebecca?
So thank you, Burt and John, for your presentation and demo. Once again, I would like to thank everyone for joining the webcast today. We hope that everyone found today's presentation to be informative, educational, and insightful about the CA LISA Service Virtualization tool. At this time, I would like to open the floor for any questions that the audience may have for Burt or John. If you do have a question, please use the raise hand function and we can unmute you and open the floor to you. It looks like that there are not any questions coming through at this time. So that wraps up today's live webcast on application delivery. A&I Solutions would like to thank Burt and John for participating in today's activities. Also, we would like to take this time to thank everyone involved in the webinar for CA Technologies and A&I Solutions. We will be posting this on our website in the near future, and if you would like anybody's contact information or the presentation, please contact Stacy or myself, and we can either email you or set up a phone call. So thank you, everyone, and have a great day.